Hello, Calculus class. This is a video for Calculus 2. I'm going over 12.2. Got 4 homework problems. Here's the first one. Evaluate the sine of 9/2 pi. So notice that angle is pretty big. 2 pi is a complete revolution. 9 divided by 2, the number in front of pi is 4.5. So really, this is like sine of 4.5 pi. That's a big angle. So let's make a coterminal angle by subtracting off 4 pi, because 2 pi isn't big enough to subtract off. It's nice to have your angle between 0 and 2 pi when you're talking radians, because 2 pi is a full revolution, a complete circle. So this is what I did. Let me lower this here. So here's the solution. I wrote it as sine of 9 pi over 2. It looks better that way. And then I subtracted 4 pi from the angle, because 4 pi is a multiple of 2 pi. And 9 pi over 2 minus 4 pi, when you get a common denominator, is going to turn out to be sine of pi over 2. This is an angle that's inside the interval 0 to 2 pi. And then what you do is you look at the unit circle handout that I put on Learn. And here's a quick picture of that handout, kind of. So you draw, there's the unit circle, and notice pi over 2 is right here, pi over 2, it's a quarter turn. The sine of an angle is the y-coordinate, so that's why my y-coordinate, I put it in orange to emphasize the sine of an angle is y for the unit circle. So what's the sine pi over 2? 1 is the final answer, 1. And we got that from the unit circle sheet. So for this section, use that unit circle sheet. And for the final exam, for any trig question, sometimes that unit circle sheet will be very helpful, because the sine of an angle is equal to y. So when my angle is pi over 2, you just go a quarter turn. That's pi over 2. This is pi, 3 pi over 2, back to 0 or 2 pi, same thing. So 1 is my final answer. Let's go to the second question now. Find all values of theta. Find all values of theta, that's a Greek letter, that satisfy the equation the tangent of theta is equal to 1. So tan is short for tangent. So the tangent of some angle theta equals 1. What angles theta make that equation true, where theta is going to be inside that interval 0 to 2 pi. So the first thing to observe is that 1 is a positive number. So where is tangent positive? That's what you want to ask yourself, because since I'm trying to find the tangent of an angle is equal to positive 1, we want to find which quadrants is the tangent of an angle positive. So let's see what we have here. So notice that the tangent of theta is equal to a positive 1. So where is tangent positive? Here's a neat little trick you can do. You make your xy plane, and then starting with quadrant 1, you write the first letter of each word. All students take calculus. This is a little mnemonic device. So all students take calculus. So what does this really mean? It means in quadrant 1, all of your trig functions are positive. This tells you where all the trig functions are positive. So all the trig functions are positive in quadrant 1. And then in quadrant 2, S stands for sine, really. So sine and its reciprocal, cosecant, they're going to be positive in quadrant 2. And then in quadrant 3, tangent and its reciprocal, cotangent, will be positive. And finally in quadrant 4, cosine and its reciprocal secant will be positive. So I know tangent is positive in quadrant 1 and quadrant 3. So I know my theta is going to be angles in those two quadrants, 1 and 3, since I'm looking for a positive answer. Where's tangent negative, by the way? In quadrants 2 and 4, because I don't see a T in 2 or 4. Okay, so here we go. Quadrants 1 and 3, tangent of theta is positive. So use that unit circle sheet, and you'll notice when theta is pi over 4, which is the same thing as 45 degrees, if you look at that handout, the unit circle sheet, you'll notice when theta is pi over 4, x and y are both equal. So that's why the answer is going to be 1. The tangent of pi over 4 is equal to 1 because the coordinates on the unit circle are square root of 2 over 2, comma, square root of 2 over 2. And if x and y are the same, then y over x equals 1. Remember, tangent is y over x. So it's the y coordinate over the x coordinate on the unit circle. And then in quadrant 3, you'll see from the unit circle, phi pi over 4. The x and y coordinates are the same, so y over x equals 1. So the tangent of theta is positive 1 for those two angles of theta. Notice pi over 4 is a quadrant 1 angle, phi pi over 4 is a quadrant 3 angle. Okay, let's go to the next question. Sketch the graph of y equals the sine of x. So here again, you can use that unit circle sheet. And all I did was just label 4 different angles. Theta equals 0, pi over 2, pi, and 3 pi over 2. And since I want to graph y equals sine x, I know that the sine of an angle, theta, is going to be equal to the y coordinate. So the sine of 0 is going to be the y coordinate, which is 0. The sine of pi over 2, a quarter turn is pi over 2 radians, is going to be 1. So here's what we did next. I labeled these points. So the sine of 0 is 0. The sine of pi over 2 is 1. So that point is input pi over 2, output 1. Input the angle pi over 2, you output the y. Okay, what's the sine of pi? Is 0, because pi radians, the sine of pi is the y coordinate, which is 0. And then 3 pi over 2, what's the sine of 3 pi over 2? It's a negative 1, because that's the y coordinate. So the x-axis, I just wrote the angles. 0, pi over 2, pi, 3 pi over 2, 2 pi. Because x is your input, which is your angle in radians. And then your output y is going to be anywhere from negative 1 to 1. Notice all the y coordinates are somewhere from negative 1 to 1. And then you just connect all the points and you get that curvy looking graph. I made it heavy from 0 to 2 pi, but this goes on infinitely in both directions. Notice, for fun, I did negative pi over 2. Negative pi over 2, you go clockwise a quarter turn. And so 3 pi over 2 is coterminal with negative pi over 2. In both cases, you get the y coordinate negative 1. So notice negative pi over 2, negative 1. That point is on the graph. Okay, and now we got just one more question here. It says verify the trig identity. Secant theta plus tangent theta, all in parentheses, times, in parentheses, 1 minus sine theta, and that equals cosine theta. So this identity is true for all theta, they're telling us. All we have to do is show that really is true. So what we're going to do is look at the more complicated side. The left-hand side is more complicated. So begin with the more complicated side and then deduce the right-hand side. If you can do that, you verified the trig identity. So the first step I did is FOIL. I FOILed the binomial times the binomial. And then what I did after that, as a rule of thumb, change everything to sines and cosines using your identities. So let's begin. So solution. Begin with the more complicated side, LHS, which means left-hand side, and deduce RHS, the right-hand side. And the right-hand side is simply cosine theta. Okay, so let's FOIL out the left-hand side. So when I do first, outer, inner, last, this is what I get. Secant theta minus secant theta sine theta plus tan theta minus tan theta sine theta. And then change everything to sines and cosines. So you have to know these trig identities, but of course, you don't have to memorize them because this is all open book. That's the one perk to all this online learning. So from your identities, here we have change everything to sines and cosines. So another name for secant theta is 1 over cosine theta. That's a reciprocal identity. Secant and cosine are reciprocals of each other. So secant theta is 1 over cosine theta minus secant theta, once again, is 1 over cosine theta. And then this sine theta is good because it's in terms of sine or cosine, so I just rewrote it. Plus, another name for tangent is sine over cosine. That's another identity. So have those identities handy. Change everything to sines and cosines. Minus, and then here again, tan theta I wrote as sine theta over cosine theta. And then sine theta over here I just rewrote. Okay, let's simplify. So when you simplify, you get the first term was 1 over cosine theta. And then this term, I just multiplied the numerators. 1 times sine theta is sine theta. That's all over cosine theta. Because sine theta is like sine theta over 1. So this is just going to be sine theta over cosine theta, which is right there. Plus, and then the third term is sine theta over cosine theta. Minus, and then this sine over cosine times sine. Well, sine theta times sine theta is sine theta all squared. But the easier way to write sine theta all squared is to put the little square right to the left of the theta and high. So sine squared theta means sine theta all squared. In other words, it's sine theta sine theta. Okay, and now notice these terms drop out. They cancel because they're opposites. So what I'm left with is 1 cosine theta minus sine squared theta over cosine squared theta, which I have here. Common denominator we have, so I wrote equals a single fraction of cosine theta downstairs, and then we subtract the numerators for 1 minus sine squared theta. But this numerator is a Pythagorean identity we can use. 1 minus sine squared theta is the very same thing as cosine squared theta. That's a Pythagorean identity. So we use a lot of identities to verify identities. Okay, and then what's cosine squared theta over cosine theta? It's just cosine theta, because this cosine theta on the bottom cancels out with one of the two cosines on top. Remember, cosine squared theta really means cosine theta, cosine theta. And that's what we had to show, because cosine theta is the right-hand side. So checkaroo, we're done. We've shown the left-hand side is equal to the right-hand side. Done, done. All right, hope you enjoyed that or got something out of that. And I'll see you later. Bye-bye.